Hi, I'm Kel Guerin, co-founder and chief innovation officer at Ready Robotics, and I'm so excited to welcome you to Ready Robotics' presentation at the AmpEd Manufacturing Career Summit. I'm so excited about this event because it's all about the future of manufacturing and the people who are going to bring manufacturing into the 20th century. And that's really all of you who are interested in a career in the manufacturing space. At Ready Robotics, we build software that it makes it easier to use industrial robots. And robots are used kind of everywhere in the manufacturing space. But the issue is they're actually not used enough. And there's huge bottlenecks in the manufacturing space because of this, because there's not a huge amount of automation. Ready Robotics is trying to solve that by building software that makes it easier for anyone to use a robot, which means it's easier to get started with robotics, it takes less training, and more people can enter this industry and actually create value and have really rewarding careers in the manufacturing space by working with robots and automation. So my background is actually in robotics. I have my PhD from Johns Hopkins University in robotics, where I really studied the idea of how to make robots easier to use. So I've actually been in the robotics space for about 10 years. I've worked in systems for deep mining, space exploration, as well as surgery, and now manufacturing. And what I found in all of those different fields was the commonality was that when a person started to interact with this technology, with this robot, whether it was they were programming the robot or they were controlling the robot to move it around, it was very challenging. And so what we focused on was how to build a software system that would make it dramatically easier to work with these robots, specifically when programming them. And that technology got spun out of Johns Hopkins into Ready Robotics, and now Ready has taken on that mission to actually create that very usable software. So let's talk a little bit about why robotics is so important to the manufacturing space. Because when you think about an industrial robot, you're probably thinking about something like this guy, right? A very big robot, maybe it's on a big assembly line or working in a car factory, something like that, right? And that's typically where most robotics in the manufacturing space are at. They're at larger production lines that sort of have been big enough and complicated enough to justify using robots. Now robots are being used all over the place, and chances are most of the products that you use every day have been produced by a process that has some type of robotic automation. Now the issue is that a lot of the things that we use every day are not produced using automation. They're produced by hand. And that's a huge issue because there's something called the skills gap. And the skills gap is a sort of fundamental trend in the manufacturing space where the people who are working in manufacturing are retiring, and all of that knowledge is leaving the manufacturing space, and it's very hard to find people who are able to do it again. So there's actually 800,000 or so unfilled jobs in the manufacturing space that we literally can't find people to do. And that number is supposed to increase to something like 2 million in the next 5 years. So manufacturing is really in trouble from that standpoint because we can't find enough people to actually do the jobs that need to be done, all of those different production processes. Now, what's awesome is that we have robotic technology that can help with these type of production processes. A robot, instead of the person sitting there doing that task, a robot can end up doing that task. And that means that the people who are working in that factory are more efficient because the robots are doing sort of the dull, dirty, and dangerous tasks, and people are freed up to be more creative and problem solve and do the complex setup that's required, all the things that really take this brain up here rather than sitting there putting a piece of metal into a machine all day long. So robots are really poised to assist in a lot of different areas in manufacturing, more so than they have been before. And we're ready to see a huge explosion of robots in the manufacturing space. The problem is that we can't find enough people to actually put those systems into production. right? We just talked about how there was a skills gap for manufacturing workers. The same skills gap is there for people who are capable of putting in robotic automation. And if we look at the number of manufacturers in the United States alone, there's around 250,000 manufacturers. There's only roughly 80,000 people who are capable of working with an industrial robot. That's less than 1-to-1 ratio, right? So the bottleneck is that to getting these systems into the field is that we can't find enough people who are actually capable of putting those robots in the field. So one of the key things that's keeping that number small, the number of people who are actually able to use robots, is the fact that robots by themselves are generally very difficult to program. So a traditional industrial robot is going to have a teach pendant like this. It's going to have some number keys and a screen, and you're going to have to write a specific language for that robot in order to give it commands so that it can actually do the work that it needs to do. The issue is that there's more than 70 different industrial robot brands, and each one has a completely different programming language and often a completely different teach pendant, right? So you're going to end up having to learn a huge amount just to learn one robot, because you have to learn this new language, you have to learn these specific things for this robot. But then if you ever want to switch to a different robot, now you're actually going to have to learn a lot of that all over again. So it means that there's a huge barrier, in some cases 70 hours worth of training just to learn the basics of moving the robot around. And that's a huge barrier if you want to get started in robotics and get into using robots in the manufacturing space. So it's no wonder that there's so few robot programmers out there who are capable of doing this. It's not a surprise that all of these different factories have a very hard time installing automation, because when they go out and look for people who can actually do it, they can't find anybody who can actually do it. And the people who can are usually slammed with work, and you're looking at a huge amount of lead time before they have the time to actually install those systems, because there's such a backlog of work. So it's a huge bottleneck in the entire industry for getting these robots into production because they're so difficult to use. So let me talk a little bit more about what we do here at Ready. So I said that we build software that makes it easier to use industrial robots, and I've sort of showed you why that's an important problem to solve. That each of these robots is different, and each one is sort of uniquely difficult to program and learn how to program. So what we're building is called ForgeOS. ForgeOS is a universal operating system for industrial robots. Think of it like Android for phones or Windows for laptop computers, right? It's a universal operating system where you have one platform that can work with a lot of different phones or laptops, or in this case, robots. And what ForgeOS does is it makes every robot very similar in terms of the software that can communicate with that robot. So we're here in sort of the main space of our robot testing area, so it's a little loud because we've got a lot of robots moving around all at once. But let's take a look at this system right here. So this is another robot by ABB, and that robot right now is doing a simulated lathe tending task where it's basically taking small, round cylindrical objects, putting them into a machine, and then taking them out once they're done, right? This is a very typical testing work cell that we will build out because the robot needs to actually interact with a very precise device, and so it's useful to test our software in that circumstance. But let's actually look at what's driving the program of this robot. As I said before, over there with the FANUC, we've got, every robot has its own teach pendant, and that's very difficult because each robot is difficult. You saw me with the Forge teach pendant over there with the FANUC. We've got exactly the same teach pendant here running Forge that is actually controlling this robot. And if we look at what's going on here, we can actually see our application called Task Canvas. Now, Task Canvas is a very simple building block-based software, and what it allows you to do is take everything that the robot can do, as well as all of the other things in the work cell the grippers. There's 2 grippers on that robot. There's a little, there's the little chuck that's opening and closing on the vise. All of that stuff is broken down to a building block in Forge that you can then program with, right? So you take all of those building blocks and you put them together into a very simple flowchart, which means that now instead of writing lines of code for the specific ABB language or the FANUC language or any of these other robots, instead you're writing a simple flowchart program using these building blocks. And the building blocks are the same for any robot that you decide to work with. So the move block that's making the robot move to a specific position is going to be the same move block for this ABB, for a FANUC, for a Yaskawa, for an Epson, whichever robot it is. And then underneath, Reddy and our software team have done the work of actually making it so that that block communicates in the native language with the robot that you're actually using. The power of ForgeOS is that we've abstracted away the complexity and the differences between each of the robot and left an interface that you can then use and learn once and learn very quickly in minutes. It takes literally minutes to build out a program to move the robot around. You can learn that once and then you don't have to learn it again when you switch robots. Now, why would you switch robots? Well, there's a lot of reasons. Different robot companies build robots that have different capabilities. Some favor speed, some favor precision, some have different form factors, some can lift more than others. It's just like why we buy different computers from Dell or Lenovo or Microsoft. It's because we want the specific capabilities of that hardware. But all those computers still run Windows. Same thing in the phone space. There's lots of different Android phones. All of those phones run Android. And it makes it very easy to use them because they are sort of unified by that common platform, by that operating system. And that's really what ForgeOS is doing for the manufacturing space and for industrial robots by making all of these robots similar so that you don't have to learn anything new when you go out and actually use them. So the reason this is really exciting is it makes it dramatically easier for someone to become a manufacturing automation professional, right? If you want to work with robotic systems, it's now dramatically easier to learn how to use those robots in an actual production setting, whereas before you'd have to learn the specific programming language of the robot, you'd have to learn all of this stuff, and then none of that was translatable to a different robot. So when the company you're working for says, hey, we can get a great deal on these other robots, they're actually interested in doing that because you can say, oh, okay, well, they still run Forge, so I know how to use them already. So yeah, go ahead and switch, right? You have that kind of flexibility. And that also means that because it's much easier to learn how to use these systems, that we'll have more people choosing to enter a career in the manufacturing and automation space. Remember those 80,000 robot programmers that are out there that are hopelessly outnumbered when it comes to the number of manufacturers just in the United States? Well, this is a problem that we can solve with easier to use software, because now anyone, maybe one of you who are interested in getting into the automation space and becoming a robot programmer or a professional who works with industrial robots every day, are now able to do that. It's dramatically faster and easier for you to learn the skills that you need to actually enter that profession. So back behind me, you actually see a very typical industrial robot work cell. This is a FANUC 710IC50. It's a fairly heavy-duty industrial robot. It can lift 50 kilograms and move extremely fast. And it's actually working alongside an older machine CNC lathe. And this is very typical, where you'll have a newer industrial robot working alongside an older industrial machine. And that means that that robot actually needs to be able to interact with that machine. So a lot of what an automation professional needs to learn and understand is not only how to program the industrial robot, but also make the industrial robot interact with that machine tool, right? The robot has to put the part in the machine. The robot has to make sure that the door is open before it does that, right? So that it doesn't crash through the door. It needs to be able to tell the machine to actuate its collet so that it actually closes and holds onto the part. It needs to tell the machine to run. The machine needs to tell the robot when it's done, right? All of this stuff that the robot has to interact with in the machine, and then also the gripper that's holding onto the parts that are going in the machine. All these different items and peripherals that the robot has to work with in this industrial cell all have to be programmed as well. So the power of Forge is not only the fact that you can program easily the industrial robot, but you can also program all of these other components in a full industrial work cell very easily. And from an automation professional standpoint, if you're thinking about starting a career in the manufacturing space with robots, then you need to be thinking about what are the skills that I'm going to need, not only just being able to program the robot, but also deal with all of the rest of this stuff that is in that industrial cell. There's a whole nother side to the robot and automation space that I haven't really talked about, and that is the software developer career opportunities. So when we think about robotics, robots are these really powerful physical devices. They can move very fast, they can lift heavy objects, all of that great stuff, but they're fundamentally driven by software. Without software, they're just a piece of metal sitting there not doing anything exciting. So software development is a really key piece of the robotics space as well. And this, again, traditionally has been a difficult space to get into because every robot was completely different, right? If I built some cool piece of software that would, let's say, allow me to pick up objects, I'd have to write a driver for a Yaskawa or an ABB or a UR or whatever robot is working with that device, with that piece of software. And the software interfaces to those robots are as varied as the programming interfaces, so they're different for every single one. Well, what ForgeOS does, it allows you a common interface for programming and writing software that works with all of these different robots. So if you're interested in software development, the software space for robots is a really intriguing area to look into. Because if you're coming from another industry where you've been thinking about things like C++ or Python, programming languages like that, if you've been playing around with a Raspberry Pi or an NVIDIA Jetson device, any of those type of experiences, then you should think about what software development you can actually do in the robotics space, because there are really hard challenges in manufacturing. Robots that can do the things that we actually need them to do in the real world takes very complex and really well thought out software. And if you're that type of person where you're excited about writing software, then there's a whole host of really exciting problems to solve in the manufacturing space. And now because of tools like ForgeOS, you actually can develop those programs and not have to implement them for every single robot. You can implement them once, and then they just work on any robot running Forge, just like Android or Windows. So there's a huge amount of opportunity in the robotics space, whether you are thinking about working with robots on a day-to-day basis, or you're thinking more the developer route where you actually want to build software for robotic systems. Either of those are an incredible opportunity, and there's a couple of things that you could do to get started right now. First of all, you can go to ready.academy, our educational resource center, where you can take 80 hours of video courses and really learn about the fundamentals of robots and how to program them using ForgeOS. And that'll really kickstart any type of other automation activities that you're interested in doing. And then if you're interested in learning more about our software, you can go to ready-robotics.com and learn more there. And also, if you're interested in being a developer and pursuing that route in the manufacturing industry, then go to forgeos.dev. That's the address. And at forgeos.dev, you'll actually be able to sign up for an early access to our developer license. So when we release the Forge SDK, where you actually will have the tools to build all of those different software applications for robots, then that's the tool that you're going to be using, and you'll have to have a developer license. We're actually pre-registering people for that, and if you sign up today, you can actually get one of those for free. So go to forgeos.dev and then enter the code A3 when you actually sign up. It'll ask you for your name and email and all of that. Put in A3, capital A and the number 3, and that will be your code, early access code, to actually let you have one of these developer licenses free of charge. So that's a really great opportunity if you want to pursue the software side and think more about the software applications, the apps that are going to really define the robotic space in the future. I hope you've enjoyed this brief look at the manufacturing and robotics space, and also the really exciting careers that are possible in this space, whether you want to interact with robots in a production environment, or you're more on the software side and you actually want to develop new software for new robot applications. I'd like to thank everyone at the AMPED Manufacturing Career Summit for inviting us to attend, and I hope you enjoyed this. Thanks so much.